Good afternoon, everyone. Thank you so much for waiting. I hope you all are doing well. By allowing transportation planners and designers to simulate multiple scenarios and test the efficiency of various safety measures before to implementing them on the roads, traffic simulation technology has the potential to improve road safety in India. In order to predict potential problems and develop mitigation strategies for scenarios like high traffic, varying weather conditions, and driver behavior. Also, we can use traffic simulation to create and test modern innovations like motor vehicles volume and smart traffic control systems. So, we would like to welcome you all to today's webinar on road safety, leveraging digital solution and traffic simulation. Before going into webinar, allow me to introduce our organization. So Capricorn is India's leading design and construction management technology solution provider for architecture, engineering, and construction. We are one of the Autodesk largest platinum partners, along with an authorized training center. We have more than 300 dedicated team members, and Capricorn is serving over 20,000 clients in the AC industry and related industries. Capricorn has contributed significantly to the country's adoption of computer-aided design for more than 3 decades to increase your productivity and lower project risks. Capricorn Technology is now a Win0 company. I can say that with honor. The historic brands US CAD from the United States, CADline from the United Kingdom, Capricorn from India, and A2K Technologies from Australia were merged to create Win0, one of the largest Autodesk Platinum partners. Win0 is committed to educating its customers about how the technology they use can help them get closer to net zero in the future and build a more sustainable society and environmentally friendly future. So that was a quick overview of our organization. We shall now proceed to today's agenda. We shall move forward with the following agenda in today's webinar. Today's technical session will be conducted by Shubham Vani, who is working as solution specialist in roads and railway for Capricorn Technologies. The major focus of today's session will be on alignment and profile optimization, followed with corridor optimization, and also will be covering traffic simulation with mobility simulation and line of sight analysis. Also, we have Mr. Vijay Dhale with us, who is a transportation engineer in City and Industrial Development Corporation, CITCO. I would like to welcome you, sir. He'll be guiding us with some important aspects of traffic control devices later on in this webinar. And lastly, the webinar will be followed with question and answer session. So I would request all the participants to write the questions in the chat box and will be answered by the end of the session. So going forward, I request Shubham Vani to take over from here. Shubham.
Thank you, Dipali. Hello, everyone. I'm Shubham Vani. So we'll be taking over the webinar from here. Before going forward to workflow of webinar, the webinar will be, I would like to a small audience poll to help me to understand my crowd. So Dipali, can you please pull up the audience poll?
Yes, sure, Shubham.
So attendees, please participate in poll for understanding, better understanding to how it's when what is your role in your organization. So most of the people are participating. So most of the people are heavy engineers, the 29%, let increase 29. And most of the people are traffic engineer. So the people are participate in polls. Most of the people are highway engineer or maybe safety engineer as well. So thank you for the quick response. I'll just end the poll, share the results. So, so let quick into jump into the my InfraWorks screen. Let allow me the moment. So I'll just jump into the InfraWorks model. So here the InfraWorks interface that will be very helpful to create an any 3D model in InfraWorks. So here it is the most of option is open new and model builder. So we can create a model from model builder itself. So I'll just click here model builder and just I'll set as aerial view of the map from here and just search here. You want to locate any create any model from itself from here. It is the same interface like on Google Map, but there is some the map integration with Microsoft Bing. So I'll just just enter here the location. Just I want to create a model. Just creating a Jalgaon, Maharashtra. So creating a model, here some features like draw rectangle, the draw polygon, and you have an import polygon shape as well from here. So I'll just click here, draw rectangle, and just somewhere around here, just capturing that area as a 3D model. Uh, Click here some model name, polygon, and here the description as well, and select a coordinate system is LL84 and just click here to create model. I'll yesterday capture a model, so I'll just not created any model right now. I'll just click here the capturing model as well. So here it is the interface of InfraWorks itself. So I'll just creating a proposal from here. I'll just create here, click here, and most of the proposal I'll create here the profile optimization like corridor optimization, junction and mobility simulation. The I'll created the model. The default model is master, so I'll just create from here add, and the same model will be copy pasted as in proposal from here. So I'll just go into the profile optimization model, and I'll show you the a showcase of overview of profile optimization. So just click here to analyze, and in analyze panel we have the option of transportation. In that transportation we have the profile optimization tool, the corridor optimization tool, traffic simulation, side distance tools, then job monitor and mobility simulation. The profile optimization and corridor optimization tool will be used from cloud itself. I'll just select the some of here one created horizontal alignment and corridor over here can show that alignment. I'll just quick open here the profile view from here, this profile view. The green line represent the existing ground over here, and the blue line represent the our active profile, right? So I'll be taking some profile optimization for our better cut and fill volume generation. So I'll just click here transportation and go to profile optimization tool. Just click here, and the profile optimization tool will appear here. I'll just select the road as a name is webinar, and the design speed will be 80 kmph. So here the most of the option is road, bridge and tunnel. Just the road alignment, I'll just select the road component and optimize it. Before optimizing it, I'll just showcase the advanced settings over here. The maximum grade will be optimizing 6 percentage. The minimum PI spacing will be 50 as is defined over here. And here are some PI elevations, the 00 station and their elevations, the number of here. I'll just confirming the quantity option as well. You can select over here and borrow and waste bit as well. Then going into the construction rules will be used as a bridge as tunnel by default will be selected over here. And go to construction and earthwork cost. I'll just select over here, just downloading some files or data and just select click OK. And we'll be going over here the optimize it. It automatically optimize by using the cloud platform itself, and it gives some profile optimize over here. Just I'll clicking over optimize it and just open the job monitor over here. In that job monitor we have a optimized corridor and profile already over here. I'll perform yesterday. I'll just click over here for the report, optimize report. I'll just click over here report. Simultaneously, we can also open its result over here, the IMX file, which we some yeah the profile optimization will be successfully completed over here, and the profile will be optimized, some adding more PI, and the ASTO standard will be considering over in InfraWorks. So there is a profile information over here, the number of uh, the design speed and length of that the corridor, number of PI over here 13, the minimum and maximum grade will be 3, and minimum spacing between PI will be 50. The another tool will be focusing over the mass hole diagram itself, will create the mass hole diagram for our earthwork quantity and estimation purpose. Then we have the cross section, the 0 to 140. There is a cut and fill area over here. The all report will be showing the showcasing of profile optimization, and here it is the volume report over here. Then list of PVIs will be calculated automatically by using cloud platform. I'll just go close over here the profile optimization and just go into the another proposal over here, the corridor optimization. I'll just select corridor optimization proposal and just go into the any site. I'll just select these sites and go into the transportation and selecting corridor optimization tool. I'll just defining over here the straight line, the PI points over here, and it cloud will be automatically calculate the over here the alignment, and there is a profile automatically. So I'll just defining a path from here. You can say see, and there is the road, the bridge, tunnel. You have to input the road alignment over here. I'll selecting 2 lane road. Just click on OK. Just go to advanced setting over here. I'll just showcasing the construction rule over here. The grading limit will be 10 meter. Cut and fill slope will be 3:1, and fill slope also as a 3:1. I'll just going into the alignment constraint over here. I'll just showcasing the minimum radius will be 280 meter, and profile constant the minimum or maximum grade will be 6%. Just showcasing the construction artwork. Just click on OK, and when we'll optimize it, there is a number of point will be 4, the 4 PVI, 1, 2, and 3, 4. I'll just go here, optimize it, and the job monitor it shows itself. The report will be showcasing over here. Profile will be successfully optimized, and the profile report as the same as an corridor report, same as an profile report. I'll just show some profile report, corridor report over here, corridor optimized report. There is a red line will be showcasing our existing line, and will be optimized corridor horizontal alignment will be green showcasing. So the final alignment will be given as in this format. You can show by using open the result over here. Just I'll clicking over here, the downloading the IMX format file. I'll just show the final alignment will be how it will like the profile and all. I'll just creating one more proposal for here. I'll just confirming yes. The name is corridor 0. Just open the corridor 01 model and just see here the alignment will be placing over here. I'll just turn off the corridor optimization tool and the alignment will be automatically generated over here. I'll just show the profile of the corridor. The corridor is automatically placed with horizontal alignment. The number of PVI will be add and all. So you can see over here, the alignment will be passing this side. You can change the alignment PVI as per our conditions. I'll just picking this PVI into a main stream. I'll just selecting and the drop down will be. I'll just remove this PVI from here and the straight tangent will be updating over here. So it will be goes up down. Okay. So let's move forward. I'll just going into the another proposal. There is a junction. To manage. It will be take a time. Can see over here the corridor optimized will be showcasing form. I'll just define over here the corridor for the junction. Can simply draw over here. I'll just showcasing the corridor replacing over here at the junction. I'll just placing the component of a road over here at that junction for our traffic simulation purpose. I'll just create a road by using component road. I'll just select element based method. I'll draw the one corridor over here for our traffic simulation purpose. Just defining one more corridor and it's automatically created an intersection, right? So here it is a intersection over here. I'll just click over here the intersection and the changes this property into a circular roundabout. So it will be goes appear here circular roundabout. You can see over here. I'll just defining a traffic area zone by going into analyze. Just from here, just go into the traffic simulation. I'll just defining over here the study area. When we are going into the traffic study area, we have an two palette over here. That is the study area one, and I'll just simulate the model. I'll just quick simulate over from you over here. The result volume will be off. Otherwise, you can calculate as a per lane per approach as well. The threshold will be in second. We have some queue times over here. You can delay threshold set over here as in 55 is a by default. You can say set what is your delay threshold. I'll just quickly simulate from run simulate options over here. and it will be calculated as a report format as well as a animation format as well. So I'll just click on the run simulation palette. So it will be take a time. It's completed. So here it is a animation player. You can click or play, and that will be here. The car will be appear here. So this is a zone. In that zone, we have some demand over here. So in that, whatever the junction, whatever the you are trying to design highway to probable, we have on some traffic study as well. Okay, that's right, being done by someone on sites, or you have some toll data over here. Whatever data you may have access throughout the government agency for the demand of that particular of roadway. We are designing maybe expansion for the new corridor for the expected demand for that 10 year to 20 year. So on that, so we have some we account for the weather, whatever the lane or how much ever assemblies, whatever the design we have for the corridor is sufficient enough, right? When the queue times for all the vehicles at every junction are okay, are acceptable, right? That is the thing that needs to be considered before designing any corridor. So we can run that and simulation and generate the report as a entire the trip of vehicle, right? So we have some report over here. I'll just click over here and selecting some traffic folder, simulation folder 2, and automatically all the report will be generated over here. I'll just select the quick simulation of vehicle, and the CSV format, sorry, the Excel format will be appear over here. I'll just go into the vehicle summary. Here it is the zone which we have that some demand, and the summary of our vehicle. Just be over here. The result of the detailed vehicle, the small car, and the departure timing over here from 8 a.m. to 10 minutes over here. So I'll just see CO2 NOx. There's the format of report over here appear. I'll just showcasing corridor of that traffic analysis panel over here. I'll just okay over, and you can edit your traffic demand as well as traffic division from here. So here it is that our panel. So I'll just click over the demand. Here it is the demand divisions. In demand division, we have some ratio of our car. Small car will be 40%, medium car will be 10%. It will be complete 50. Okay, then 30% will be large car, SUV 10%, van also 5 and 5%. It will be over 100%. You can put your data by given by our from site traffic volume study data. You can put over here and run that simulation by clicking over here. I'll just simply run that animation, and the queue time and all vehicle time will be appear here, and automatically over here that the some traffic signs that road safety will be leveraging that technology over here. You can see the traffic signs and all will be warning signs, and speed limit will signs will be appear here. In roundabout will not require that traffic signs, sorry, the traffic lights, and over here I'll just simply change that roundabout to normal junction, and then will appear over here the signaling of that parameter over here. I'll just showcasing that some demand over here. I'll just increase the demand by using that. So there is a zone 1 appear over here, and that the demand second, third, fourth goes appear on that vehicle. I'll just putting over here 100 vehicle. This demand will be increases, and also the zone 2 will be goes appear over here. I'll just define 110, and then third zone will be 80, and just clicking over 90. Some click OK and just run that simulation once again. You can see over here 380 trips will be generated and the traffic flow will be smooth, and there is no travel delay time, and that queue time over here, that will be exactly simulate with no delay over here. So that is a quick overview of traffic simulation. Just going into another parameter over here, like this called as site distance. So I'll just going into the transportation panel and just go into site distance over here and just selecting a roundabout. Otherwise, you can select just I will just change that junction type into a normal junction. So just showcasing our power of the infra works, and that can be used for the site distance as well as our traffic simulation purpose. I'll just defining over here the approaches will be for 7 road, just say this road, and just traffic control we will no control, and here it is a menu over this left turn. So I'll just analyze it. It will be showcasing over here. This is a site clearance. Site clearance is okay, and there is no site failure and there is no obstruction. I'll just create over here the obstruction by using the create and going into environment. I'll just creating some city furniture over here. I'll just pick the one off tree over here and just selecting that parameter and analyze once again. So most of the in city furniture we have also the signboards over here. You can put the signboards of traffic signboards and other warning signboards. The stop signboards, warning signs will be putting over here, that it's help to achieve our safety and road while road designing. So I'll just put over here some tree and will be analyze some side distance. That can be a case, it will be failure over here, just side failure. You can see over here the vehicle will be turns on left. There will be some the failure of that tree. There's some side visibility over here, you can see. This is a quick overview of side distance. We can see the left turn or right turn will be feasible or not while are turning the vehicle over here in the intersection, right? So I'll just go into a mobility simulation. There is the last part of our webinar. Just going into the quick overview of mobility simulation. Just defining mobility simulation. So I'll just speak mobility simulation purpose. The site we have on the rail over here. This is the junction, the railway junction over here, and the rail alignment will be passing through this area. I'll just define over here as a rail corridor. Just go into analyze. From transportation panel we have an mobility simulation. I'll just click over here for the mobility. I'll just defining study area, traffic study area. I'll just go into the mobility simulation by using right click. I'll just define here the warning sign is selected traffic study area does not contain an intersection. Okay, I'll just define okay, and mobility simulation will be opening another window. There is the window over here. I'll just defining some rail section over here. I'll just showcasing. So here it is the platform 1. So you can see over here, and there is an some platform, the platform 1 and platform 2 over here. Just click over platform 2 and this overview of that alignment, the railway alignment. I'll just defining some travel demand by using just simply first going into network and just trial. I'll just defining here's the trials. Okay, I'll just close over here and defining some demands. You can also see the demand division. You can set your division from here. I'll just defining a demand, the that kind of vehicle, that kind of matrix we will be see over here. The for our mobility simulation, I'll just defining from over here and just go into the services. I'll just pick the transport type as a train. Okay. In that train, we have some specific stands over here and the service area. I'll just defining service area and type over here. I'll just simulate by using quick simulation panel. I'll just simulate over here. I'll just play the animation. There will be here the only 101 and trip will be generated over here. The mobility simulator is still going on, that the people are standing from one zone to the platform over here, and the train will be in stand one. There is the train and it will be goes on in that platform. Just I'll just simulate once again. This train will be appear over here in the platform, and the people will go around in the train, and just he'll be the going into the second platform and will be dropping the some people over here. I'll just run the simulate once again. So you can see over here, I'll just the train will be goes down over here. Can see another time. The 101 total trips will be generated. The people are still coming, and the mobility simulation will happen over here. So we can also generate some reports over here. I'll just run the traffic simulation once time. Just going into the reporting. From results, you can see results. You can see the walking report over here. The walking speed will be defining over here, and this level of service report. You can see the level of service report over here generated. And we can also defining some signal report and traffic report as well. So there is a report type, can see the result as well. You can see over here the CSV format and Excel format you can export out, and that mobility report. So that's it. This is the mobility simulation over here. I'll just screen off. So now I invite Vijay Dhale, sir, who is a transportation engineer in City and Industrial Development Corporation as a SIDCO in Navi Mumbai for the last 8 years. He is handling all transportation planning, networking of highway, verification of complex interchanges, and also the road safety related sign placement along with road furniture like lane marking as in the as per IRC guidelines. He has done his master's for transportation engineering from BITS Pilani in 2013. He is also a certified road safety auditor from Central Road Research Institute, CRRI. Sir, over to you.
Thank you. Hello, am I audible?
Yes, sir. You're audible.
Yeah. Thank you, Shubham.
Yes, your screen is visible, sir.
Good afternoon, all of you. Myself, Vijay Dhale, working as a transportation engineer in SIDCO, Navi Mumbai. Today, I am delivering the presentation on road safety audit. In that, traffic control devices. As we know that road safety audit is nothing but the formal examination of the new road or a traffic project in which an individual road safety audit team reports on an accident potential and safety performance. Road safety audit is nothing but is not about the opportunity to reduce the to redesign a project, or not means of the rating of the project over one project against another. And it's not an accident investigation, that is the black spot identifications. uh, Road safety is originated in UK in 1980s, and UK made road safety audit mandatory in 1991. In India, Indian Road Congress has developed the road safety audit manual, that is IRC SP 88 in 2000, SP 8 2010. The first revision is in uh, September 2019. Road safety audit is uh, as per the United Nations has launched the decade of action, uh, has launched the decade of action, uh, first decade of action in 2011 to 2013, 2011 to 2020, that targeting to reduce the road traffic deaths by 50% during that period. Now, during the it was decided during the uh, third uh, third ministerial global ministerial conference, that second decade of action for road safety, that is 2021 to 2030, targeting to reduce the road traffic deaths and injuries by at least 50% during that period. The broad objective of the road safety audit is minimize the risk and severity of accidents. It also minimize the accidents on the network, meet the needs of safe use by all users, reduce the long-term cost of scheme, improve the awareness of the safe design practices. There are the 5 basic principles of the road safety. That is, it should warn for unusual features. It should inform of conditions to be encountered. It should guide through unusual sections. It should control through conflict points and forgive for errant behaviors. As we know that safety is a function of geometry, and geometry is a function of the speed. That's why safety is derived from the safer planning and design. As per the MORTH data, the road fatalities involved in India, that is vulnerable road users, that is maximum of 70%. This data is in 2019 data. Now I am more worried about this VR use. Now it goes up to 80%. We can see in this slide there are the 2 pictures. In that, police recorded at the reckless driving or under influence of the alcohol, etc., etc. But in my opinion, we can tackle these kind of the issues by achieving the 100% of the road safety. Basically, there are the 5 stages mentioned in IRC SP 88 of the road safety. First one is the planning stage, which involves route options, layout options, design standards, impact on network, horizontal and vertical alignment, cross sections, and intersection layouts. Second one is the design stage. In that, geometrics, intersections, signs, markings, signals, lighting, provisions for VR use. uh, Next, third one is the construction stage. In that, work zone safety, safety of workmen and road users, traffic control devices, and other safety measures. Fourth one is the pre-opening stage, that is final review of finished construction in a day or and in night, and in inclement weather as usual. Fifth one is the operation and maintenance stage. In that, safety hazard identification to prevent accidents. Uh, Basically, traffic control devices is an integral part of the any road design, often the forgotten part of the road design. There is a limited information for concept design audits, generally supplied at detailed design audit stage. Reasons for lack of information is the standards are broad and allow for engineering judgments. That is, we generally follow the Indian Road Congress standards, guidelines, or MORTH guidelines. The designer has not got the right skills to design the correct signs and lines. Basically, there are the four types of the traffic control devices as per the Indian Road Congress guidelines. First one is the road signs, road markings, road studs, road lighting. Road signs is nothing but to notify, it is provided to notify the road users of regulations and provide warnings and guidance needed for safe, uniform, and efficient operations. It promotes the road safety and efficiency by providing orderly movement of the all road users on all roads. Uh, there are the five basic principles of road signs. It should be fulfill a need. It should command attention. It should convey a clear and simple meaning. It should command respect from road users, give adequate time for response. Classification of the road signs. There are the three types of the road signs. First one is a mandatory signs, which provided with a white background and red border. Second one is the cautionary or warning signs, which is generally a triangular in shape with red border and black symbol in white background. Informatory signs are rectangular in shape and which generally provided to facilitate like fuel station, eating stations, or the directions. Uh, s- Sign orientation generally we kept as right angles to the line of travel of the approaching traffic. IRC specifies the 95 degrees angle. Signboard height should not be less than 2.1 meter and not more than 2.5 meter. Material used for placement of the signboards is it should be a M25 grade of concrete, and reinforcing steel shall conform to the requirements of the IS 1786. We generally use the aluminum composite material for any road signs. Any road signs which is placed on the road, that is, it should thickness should be 3 mm thickness, and for gantry or overhead signs made with the aluminum composite material shall be minimum 4 mm thick. The retroreflective sheeting used on the signs and tested for coefficient of the retroreflections and other tests. Retroreflections sheeting generally comes with the three types, that is the class A type, class B type, and class C types. There are the two types of the angles in observed, that is the observation angles and entrance angle. Observation angle is ranges between the point 1 to 1, and entrance angle ranges between the -4 and +30. There are the color pattern for direction in information signs. We generally see on the expressway, that is the blue background signboards, which is the letter in white. In national highways, that is the green and white. And in urban and city roads, that is the blue and white. Second one is the road marking. So road marking are the line, patterns, words which are applied or attached on the carriageway. Road markings normally include longitudinal marking, transverse marking, text and symbols, etc. on the road surface. We need such type of the road markings for guiding and controlling the traffic on highway and serve as a psychological barrier, channelizing the pedestrians and cyclist movement into safe locations. There, as per the IRC guidelines, there are the 7 types of the classification of the road marking. First one is the longitudinal marking, which provides the center lines of the road or carriageway. Transverse marking is generally provided for the stops and give way marking. Hazard marking, then block marking. Block marking generally provides for the bus lanes and the taxi lanes. Arrow markings generally provide for center to guide the traffic movements uh, here. Direction marking, then the facility marking. Facility marking we generally use for the parking areas. Here, if we provide the parking areas parallel to the roads, then we generally use for the this type of the marking. And next one is the object marking. Object marking generally provide the underpass, pier, abutment, restricted vertical clearances. Third one is the road studs. Road studs are generally used to road users to guide throughout their journey. There are the 4 types of the road studs. used. That is, first one is a white color to indicate the traffic lane and center of the carriageway. Center of the carriageway. Red one is generally used for left hand edge of the running carriageway. Yellow M is to delineate the right hand of the carriageway, and green is used for to indicate the crossable edges. These type of the color road studs are generally rely on the vehicle headlights. Then another one is the solar road studs. Solar road studs generally not rely on the vehicle headlights. It is provided on the hazardous location like bridge, toll plazas, sharp curves, construction sites, railroad crossing, etc. There are the road studs. This picture shows the road studs for bidirectional roads. The spacing of the road studs is depends upon the section of the road. That is the whether it is the normal section, whether it is the warning section, whether it is the no overtaking section. The IRC specifies the all the spacings in their guidelines. Marking of the speed reduction measures. There are the two types of the speed reduction measures: speed breaker and thermoplastic bar marking, that we generally call as TBM marking. Speed breaker, we generally provide the triangular, this type of the arrangements, which specifies in the IRC guidelines, which is generally 750 mm of the width and 1800 of the height. This is used for to warn the drivers about the hazard ahead in advance. In Mumbai, the approving authority of the such kind of the measures, that is the speed breaker, is the DCP traffic. Once it approves, then we provide at the sites. Then next one is the thermoplastic bar marking, is a softer treatment to reduce the speed. One set, this is the six bars of 300 wide bar marking, which is generally provided in national highways crossing or any other roads, which is in the hazardous reach. Like we can see here, the in the national highways, there is a national highway with the crossing of the village road. We can see this type of the hazardous, this type of the thermoplastic bar marking. Next one is the pedestrian crossing. Pedestrian crossing generally used with the 2 meter, 3 meter, and 4 meter width in the crowded areas. Uh, it is when the length of the road is more than when the length of the road is more than when the length of the pedestrian crossing length is more than 10.5 meter in one go, we should provide the refuge island in between at least 1.2 meter width. At a junction, we can see this type of the pedestrian crossing marking, and at mid block, we can see this type of the pedestrian crossing marking. Next one is the road lighting. Road lighting is an effective tool to make a city livable, safe, and more conducive to social and economic activities. One of the studies revealed that the fatal crashes in urban areas can reduce by 43%. The spacing and pole height of the road lighting is depends upon the type of the road, that is whether it is footpath or cycle track, whether it is local street, whether it is arterial or collector street. This type of the lighting for is generally used for the terminal approaches. This first one is the single side pole arrangement. Second one is the both side staggered pole arrangement. Third one is the both side opposite pole arrangement. And fourth one is the twin central arrangement. Nowadays, we can see this type of the facade lightings, which generally this type of the lighting is designed to highlight special features of the bridges to enhance its overall appearance. This picture shows the in the day and night. In just 5% of the information we can see in the daylight where are caught by the eye at the night. For better safety, these are the 7 golden rules that that we know actually. Always wear helmet and seat belt while driving. Know the road signs and obey them. Avoid rash driving and unnecessary risk taking. Give priority to pedestrians on zebra crossing. Do not mix drinking and driving. do not violate speed limit, do not use mobile phones while driving or during crossing the road. These are the reference IRC codes list. For the practice of the road signs, we generally use the IRC 67 2020 2022, and for practice of the road markings, generally we use the IRC 35 2015. Thank you. Hello,
So,
Shubham.
yeah. So I'll just share my screen once again for a question answer round. I'll just share. So now the time is by question answer round. I'll just pick up some questions. So, sir, the question for you. Also, how to retroreflective sheets can be useful for highway and road walls. So, can we use retroreflective sheet, right? In
Yes.
highway and road, it is useful, can be useful for highway and road walls. There is some
Yeah,
questions.
it can be useful for highways. Uh, as I mentioned, we can provide this for the underpasses, abutments, walls, and all.
Mhm. So most of the question will be king over here. I'll just answer the few questions in chat box as well. Uh, anyone we have some questions from your side, just put on the question Q&A chat box. I'm just picking some questions. What is the area limit for traffic simulation, macro and micro? So in that InfraWorks, we have, there is no limit for that. I'll just some intersection you can define some demands over here, and just you can see the micro as well as micro traffic simulations. So any questions from IS? It is good for landscape or cut and filling lands. The InfraWorks, okay. The InfraWorks is a basically tool for modeling purpose, and you can detail design further. We have an Autodesk Civil 3D tool you can use for that landscape cut and fill. Okay. So there is a very limited ROW and hill roads. So any safety measures during constructions? So the question for you, there is a very limited ROW, right, in hill roads. So there is any safety measures during construction? That is a construction stage.
Mhm.
So any safety measures during construction stage on that hilly roads? So any suggestions?
We can provide the divergent signboards,
Hmm.
or we can provide the
Barricading,
delineators,
barricading as well.
barricading the sides.
Yes.
We
Yeah.
can
Yeah.
provide the
Hmm.
delineators. We can also, nowadays we can provide the LED lights
Yes.
during the
Yes.
rides,
Yeah.
during the night time. So these type of the indicators we can use to guide the vehicles during the
Okay.
construction.
Okay. Okay. So I'll just forwarding next slide. So vote of thanks. I want to take a moment of thank you, Mr. Vijay Dhale sir, for your presence in the today's webinar. Your insight and expertise on the subject matter to be present were invaluable. We are recognize the time and effort it took for you to prepare and participate in this webinar. And we are truly grateful for your willingness to share your knowledge and expert experience with our audience. So once again, thank you for being a part of our webinar, sir.
Thank you. Thank
So
you, Shubham.
before leaving the session, I'll request to all attendees to kindly give your valuable feedback of I have a share feedback form link in the chat box. It will be take a 2 to 3 minutes. So kindly do needful. So I'll just put in that webinar chat box. We have some link over here. Just taking 2 to 3 minutes. Kindly do needful. So please give us feedback in that chat box. We have some link that chat box. It will be take a time 2 to 3 minutes. So thank you for sharing your valuable feedback. We will be delighted to hear from you. Please reach out us to us any suggestions, query, or topic you want to be discussed on my mail ID and my mobile number over here. So we also share the short videos on various topics every week as name as quick weekly technical insights. You all can have access to my previous tech insight on our YouTube channel. That is a Capricorn Technologies Private Limited, the Win0 Capricorn Technology. Please do like and subscribe the more updates and new videos. So thank you everyone for presence in the today's webinar. Thank you.